Hey grade 12s, I have decided to make a video just to go through a test for you. It says here, test yourself by doing the following questions based on an old higher grade paper, one that I might have written when I was at school. Give yourself 30 minutes for the 25 marks. And if you'd like, you could let your teacher know how you did in it. Okay, so it's entirely a calculus revision question. You should have covered the majority of calculus by now. So this test paper could see how you've done and how you know your work. Okay, so for the first question, it says determine the first derivative from first principles. So that's very important. It's telling you how you have to find that first derivative. Given that fx is equal to ax squared plus c. Okay, so this is a generic formula for a parabola. Instead of having values for a and c, you've just got variables. Okay, so the first principles is very key. You can't use shortcuts here. You have to use the long first principles method. Okay, so I'm just going to work through it with you, and hopefully by now you know how first principles roll. So, for number one, you have to always write this notation. The first derivative, the limit as h approaches 0. Okay, and the formula that you are applying for this kind of question is f of x plus h minus f of x divided by h. Okay, so that's the standard formula, if you want to call it, of this kind of question. You have to rewrite this limit as h approaches 0 every time, every line. Okay, so it's a bit of a mission, but it's very important. If you do not write it, you could lose a mark for an incorrect notation. Okay, so for the f of x plus h, that means here, whenever you see an x, you're going to have to replace it with a x plus h. So, a is there, x plus h all squared plus c. There is your f of x plus h. You then would subtract f of x. That is f of x, so you're going to subtract the whole thing, ax squared plus c, and we are still all divided by h. Okay, the next line, we once again rewrite the limit as h approaches 0. I can let my a just hang in there for now. X plus h all squared. If I FOIL that out, I'm going to get x squared plus 2 of xh plus h squared, and then plus c. And then if I times the negative into the bracket, I'm going to have minus ax squared and a minus c, all divided by h. Rewrite this again. Times the a in, I'm going to get ax squared plus 2axh plus ah squared, then plus c minus ax squared minus c. Okay, all over h. Okay, at this point we're going to be able to cancel some things. So we rewrite our limit as h approaches 0. I can cancel my ax squareds because they've cancelled each other out. I can cancel the c's because they've cancelled. Right, so what is left? At the same time, by the way, I'm going to be able to take out an h from my numerator in order to cancel with the h that's lying at the denominator. So what have I taken out? I've taken out an h. What's left? 2ax, and what's left here? ah is left. Okay, so that means the limit as h approaches 0, we're going to work out from what? 2ax plus ah. Right, now we can apply the limit. So as h heads towards 0, what's going to happen to that term? That term is going to disappear. It's going to become 0. That means our answer is 2ax. Notice that in my final answer, I do not have the limit as h approaches 0. I've used my limit now, so there is my final answer, 2ax. Okay. By the way, we should have known this answer just by looking at the question, right? Using our shortcuts, right? If you had used your shortcut, the square would have times to the front to give us 2ax, and then I would have reduced my 2 by 1 to give me 2ax to the power 1. This is a constant. The derivative of a constant is 0, is nothing. Okay, so there's your answer, 2ax to the power 1, and that is what we got over here. Okay, so you should always get the right answer, but sadly some of you tend to lose marks in the working out. This can be up to 6 marks, so make sure that you get them. They should be very doable. Okay, then we go to question number 2 that says determine, and I'm going to write the question so long, determine dx, remember that's the derivative, of 6 times the cube root of x. Okay, so let's go look at the question. Here it is. Am I able to do the first derivative already, or do I need to do some work first? The answer is I need to do some work first. So I'm going to leave my dx like that. So it's going to hang in there for now. Then I'm going to rewrite my cube root of x as x to the power of what? Remember there's a 1 over there, so x to the power of a third. Right? We have to do that initially in order to progress to use our shortcuts. Now the answer. So I need not write the dx again because I'm now actually working out the derivative. What's the shortcut? Take the third to the front and multiply it. So a 6 times a third is going to be 2. And then x to the power, reduce that by 1. So a third minus 1 will be negative 2 thirds. And there is my first derivative. Okay, using shortcut methods. Great. Moving on to number 3. The question said, if y is equal to 2x plus 10, determine what dy over dx plus dx over dy is. Okay, now for some of you, you might see this and go, what the heck, what does the dx over dy mean? Okay, we should be happy with the dy over dx, but maybe this is going to be confusing for some of you. So let's think carefully. Right. First of all, are we ready to work out dy over dx? We are. Dy over dx, using our shortcut method, because this is a straight line, if we had to go and take that 1 that's in the exponent, times it to the front, I'm going to get 2. And then if I reduce the exponent, the 1 is going to become 0, and I'm going to get 2x to the power 0, which is simply just 2. Okay? A shortcut to just think of it this way, if dy over dx is 2, and we are dealing with a straight line, what do you think dx over dy would be? It's the upside down. So if 2 is actually 2 over 1, what do you think dx over dy would be? 1 over 2. Okay? Just to confirm that for us, in order to actually work it out, I would have to take my straight line and make x the subject of the formula. Okay? So if I want x to be on its own and the subject of the formula, I would say y minus 10 is equal to 2x. Right? I've taken the 10 and subtracted it. And then I'd need to divide by 2. So y divided by 2 is a half y. And then negative 10 divided by 2 is negative 5. And then x would be on its own. I'm just going to write it on the left-hand side. So now x is equal to a half y minus 5. I can do my first derivative. So dx over dy. Right? There's my 1 up top. Take that 1 times it to the front. I get a half. Reduce it. So y to the power 0 becomes 1. And the derivative of a constant, negative 5, falls away. So there is my dx over dy, giving us a half. So to answer the question that's posed to us, dy over dx plus dx over dy would equal what? Dy over dx is 2, dx over dy is a half. So our answer, 2 plus a half is 2.5, or 5 over 2. Okay, so a slightly different style of question, but hopefully you saw what they wanted from you. Okay, we then move to number 4, which says the following for us. The curve with an equation px is equal to ax cubed plus 2x plus c, okay, that cube should tell you that we are dealing with a cubic graph here, has a gradient of negative 4 at the point 1 and 8. Right? Whenever we read the word gradient of a cubic graph, gradient is going to be talking about the first derivative. Calculate the values of a and c. So if we've got two unknowns here, we're going to need simultaneous equations at some point. Right. So the idea that we're going to do is we are going to say the first derivative, right, p dash x, p prime x, would be what? Let's work out the first derivative using shortcuts. We're going to have 3ax squared plus 2. That is the first derivative. Remember, the derivative of c, our constant, falls away. Now, if it tells us that the gradient is negative 4, right, we can say that the gradient, remember our first derivative, is negative 4. When is it negative 4? At the point 1 and 8. Are we really concerned about the 8? Not really. We are now going to substitute 1 in place of our x, like so. Okay, so let's subtract the 2, and we're going to get negative 6 is equal to 1 squared is just 1, and 3a. So what is the value of a? A would be equal to negative 6 over 3, okay, making a's value how much? Negative 2. Okay, so a is negative 2, and then how would we work out the value of, what's the other variable? Of c, right? How could we work out the variable c? We could say, okay, let's substitute in the whole coordinate into the original function, eh? So if we go 1 and 8 and we sub in 1 and 8, okay, we're going to get 8 is equal to a brackets, x is now what? 1 cubed plus 2 times 1 plus c. And then we can take our a value and substitute it in there, right? Or into a. So 8 is equal to negative 2. What's 1 cubed? 1 cubed is simply 1. So I'm going to leave negative 2 plus 2 plus c. So if negative 2 and 2 are going to cancel each other out, what does that make the c value? That makes c equal to 8. Right. So I guess we can conclude that therefore px's function value is not ax cubed, it is negative 2x cubed plus 2x plus, what's c's value? 8. We've worked out a, we've worked out c. Okay, these simultaneous equation questions are very popular, so hopefully you're getting the hang of them. Right, just moving my question paper up a little bit here. We can move to our question number 5. Right, which was possibly a little bit tricky. Let's see what it says. It says the graph of y is equal to f prime x is shown below. Right, they give you a straight line. If they give you a straight line, this is a linear function, right? For every x value, there's going to be one y value. Okay, so it cuts the x-axis at negative 2 and 0, and it cuts the y-axis at 0 and 2. Let us see the first question. 5.1 asks us, what shape will the graph of y is fx have? Okay, if the first derivative is a straight line, moving back up a level, what would the fx graph have been? It would have been a parabola. Okay, so it's slightly different as this does not involve cubic graphs, but you remember the general idea behind calculus is that if fx is a cubic graph, what would f prime x, or the first derivative, had been? It would have been a parabola. And then what would the second derivative have been? It would have been a straight line. Okay, so that's the general idea behind the calculus you've done. In this question, though, they give you the first derivative as a straight line, not a parabola that you might have expected. Okay, so working backwards, if the first derivative is a straight line, moving up a level, the original fx graph must have been a parabola. Okay, 5.2 says, explain why the fx graph is a quadratic. Okay, a parabola is a quadratic function, remember. So why would it have been a quadratic? Okay, a simple way to answer the question would be to say, if the first derivative, okay, so the first derivative is linear, right, linear as in a straight line, therefore, the function, as in fx, the one we're dealing with, must be, go up a level, must be quadratic. Okay, so like this here, you're moving up a level, except in this question, our first derivative was a straight line. So moving up, the original must have been a parabola or a quadratic. Okay, question 5.3 says, use the graph, our graph, to determine the values for which our first derivative is greater than 0. Okay, if you look carefully here, there's our first derivative. When is our first derivative positive? It is positive after x of negative 2. At x of negative 2, we are at 0. Afterwards, you are positive. You are negative to the left of x of negative 2. So to answer the question, you would say x is greater than negative 2. That's when our first derivative would have been positive. What could you add to your answer here? That x is an element of real. Okay, moving up a little bit more, the next question says, 5.4, for which values of x will fx be decreasing? Okay, so now you are using your first parabola, your first derivative graph, to relate back to your parabola. So, the gradient of the parabola needs to be negative, right? For the original parabola to be decreasing, I'm just going to scribble a little parabola here, okay? For the parabola to be decreasing, right, you're going to have negative gradients of your tangents. So when, in other words, are you going to have your tangents have a negative gradient, right? That's going to be when x is less than negative 2 and x is an element of real. In other words, bringing back our graph over here, right? There was our first derivative. Our first derivative is negative to the left of x of negative 2. So in other words, our gradients of our tangents would have been negative to the left of negative 2 when x is smaller than negative 2. Okay, so once again, we're showing the relationship between the first derivative and the parabola in question. Okay, 5.5 asks us the following. Does y is equal to fx have a maximum or a minimum turning point? And justify your answer. Okay, so just by looking at the rough little scribble parabola that I drew, we are going to have a local minimum, right? Why are we going to have a local minimum? Because if you had looked at our first derivative changed from having a negative gradient to a 0, right? It's 0 at negative 2. So the gradient is 0 when x is negative 2. And then it changed to a positive gradient. In other words, you would have been negative over there. You would have been a 0 gradient at negative 2. And you would have been a positive gradient after negative 2. So that little kind of picture that I've drawn here is talking about the parabola in question. So that's why you're going to have a local minimum. Where would that local minimum be? I think that's the next question in 5.6. It says, write down the equation of the axis of symmetry of the parabola. So axis of symmetry talks about where would you have been able to fold the parabola over? What line? That relates directly to the turning point of that parabola. And the turning point's x value was negative 2. Don't worry about the y value. We wanted the x value where it would have folded over nicely. So the equation of that axis of symmetry is therefore, let's just check the question, 5.6, write down the equation, there we go. So 5.6's answer would have been x is equal to negative 2. Okay, that is the equation of the line that it would have folded over. Right? 5.7, the last question of your test, said the following. Write down the value of f dash dash, or the second derivative of 0. In other words, what? What's the answer for when the second derivative, you sub in x of 0 into the second derivative? In other words, you would go look at the gradient of this straight line. You remember the first derivative here is shown. So you are working out the derivative of the first derivative. Or you can simply look at the gradient of the first derivative. The gradient of this first derivative is what? Change in y over change in x. You would see that the gradient is 1. So your answer for 5.7 is simply 1. A longer way to do it, you could say, what is the equation of this straight line? It would be y is equal to x plus 2, right? So your first derivative is actually y is equal to x plus 2. So if you really want to work it out, your second derivative would have been equal to what? Derive your first derivative. You would have taken your 1 up top, times it to the front, and gotten 1. Reduce the 1 by 1, you would have had 0. So your second derivative is always going to be 1. There's my answer of 1. Okay, so overall, the test I feel is pretty doable. Possibly the last part of question 5 maybe had a few tricks. Okay, hopefully my explanation assists you. All the best with the rest of your calculus studies.